You go back to the old ag bulletins, extension bulletins. You can find bulletins on cover crops going back to 1910, 1920. I remember growing cover crops in the early 70s when I was farming in North Carolina, and at that point I was the only person around growing cover crops. But the old folks remembered back in the 40s when they used to do it. So I hope you're the first spot of green there in the winter in your part of the neck of the woods, and it's going to start to catch on. So cover crops do a whole lot more than protect the land, but that's one of the things they certainly do, and that's how they get their name. When you start growing cover crops, you're really changing everything. It changes your entire farming operation. It changes everything about the soil. It enables you to bring diversity onto the farm that you couldn't do before. So it really is a major thing. You want to think about this. A lot of you probably own some of your land and rent some of your land. And you pay that rent for 12 months. Why in the world would you pay 12 months of rent and only use it for free? You think about the crops we grow, corn crop, soybean crop, put seed in the ground sometime in May, and it really hasn't established any green, and it's not catching any sunlight, it's not really pulling up nutrients for the next 3-4 weeks. And then you've got another 3 or 4 weeks before harvest when it's just sitting there and it's dead and it's drying down. And if you think of the time when you have an active plant growing in the soil, if you're lucky, it's June, July, and August, and that's about it. Maybe 3.5 months out of the year. The sun keeps shining. The nutrients, the bacteria are still working in there, releasing nutrients, and you're letting it go to waste. I mean, that's not a very efficient way to farm, if nothing else, right? So you want to kind of think of the whole year. But must be something very good. Let me put this someplace else.
Ray, you have your phone on?
Do I have it here?
Your phone, your cell phone.
Oh, I bet that's what it is. Yeah, okay. My cell phone's trying to talk to the mic. Let me put it in a different pocket. Cell phone is right there.
That's just the government.
All right. You think it's the government listening to my phone calls? Could be, I don't know. So I'm hoping that none of you went to the University of Maryland to study soils, because no hands went up when Ray asked you whether your professors told you to work with nature. I'm hoping Rafika's not out here in the audience, because he worked with me. This is my PhD student. So this is kind of the situation we have, and what we want to do is use the other 8 or 9 months and make sure we have roots out there. It's really below ground, and we're at a disadvantage when we think about our farms, because we're human beings, and our greatest sense is probably our eyesight. We have better eyesight than most animals do. But is your pooch around here, Dave? Dogs can see all right, but a dog's world consists of smells, right? A dog can smell stuff under the snow or in the next room that you won't even know is there. And so we're not very well equipped to figure out what's going on below ground. We just kind of see that bare field above ground. And we need to start thinking about what's going on below ground. And we'll see this when we go out in the soil pit. It doesn't look like there's a whole lot going on above ground. Got a little bit of rye, it's a few inches tall. But boy, there's a lot going on below ground, even right now. And I like to think cover crops as kind of a liberation for farmers. You're in this part of the country, and you drive miles and miles and miles in the middle of summer, and you see basically 2 species out there on the land. You see corn and you see soybeans. Every now and then you got Dave Brandt that's growing some wheat. And last time I looked, the wheat was a pretty good moneymaker. I don't know why it's so hard to convince people to add a 3rd crop to their rotation. Corn and soybeans seems to be it. At any rate, you can only grow what you can sell. I mean, you're going to have to be able to drive a truckload of this to town and sell it. And so you're limited pretty much. It's kind of hard to grow a couple thousand acres of arugula or something, or sunflowers or anything else. But once you start growing cover crop, you don't have to sell those. Think about it. You can grow hundreds of acres of plants that you don't have to sell. So that takes a whole lot of limitations off what you can start to play around with. And so you can start thinking about, well, I want to mix things together. I want to have things that grow well in the warm season and things that will take over. They'll grow in summer when it's hot and cool cool season things go dormant. I want to have some legumes in there. I want to have some broadleaves and some grasses. They have different kind of root systems. They do different things. So you can really mix it on up, and you don't have to bring a truckload of this stuff in and try to sell it. So once you start putting this into your farm, instead of just growing corn for 3 months, you're now growing all kinds of species. It changes everything about your farm and your soil. So this is a fairly complicated diagram, and you can sit down and kind of follow some of these arrows, but anytime you change one part of your system, like add a cover crop where you didn't have a cover crop before, where it was just bare, dead residues like you'll see across the road. It's kind of nice out here, just, you know, you can see Dave's fields full of rye, and you just look across the road and just a little bit of soybean residue sitting on black soil, doing nothing. You add that cover crop to there, and you change all kinds of things. You're adding organic matter, you're changing the temperature, you're changing the moisture, you're pulling nutrients up, you're feeding microorganisms. And so we're going to talk about temperature a little bit, organic matter, and biodrilling is a physical thing. It's essentially what people try to do with tillage but fail. The biodrilling is actually a permanent improvement to your soil. And the net result of all of this is you have less erosion, less soil loss, less chemical loss, and better crop growth, which is what we want. And more money in your pocket. You start writing the backs of those checks. And this happens pretty quickly. This is just some data from a simple rye cover crop, one species, simple standby, average of a couple of years of rye, and this is from a number of fields in Maryland and Pennsylvania. And you can see that not only did it improve soil quality, increases in active carbon. I'm trying to find the right button here. This is the active carbon, it's sort of the labile carbon that the microbes can eat readily. It's gone up significantly. Respiration rates have gone up, total carbon. It's a lot harder to find a change in total carbon. That takes longer. This is the total organic matter. The rate at which nitrogen is mineralizing has gone up. Aggregate stability has gone up. And you usually find that your yields go up too. If you do all these good things to the soil, pretty typically you're going to find in the neighborhood of 10-15% yield increases just for adding these cover crops. And these aren't even cover crops that are fixing nitrogen. We're not even talking about legumes yet. So this is a pretty typical experience all across the country, across the board. So again, you want to start thinking about what's going on below ground. Again, you know, our world is above ground. We see the above ground part, and we really don't have an appreciation for what's going on below ground. We have to use our imagination as well as instruments and things to try to see what's going on there. So we see the above ground part. We harvest that. We take some of that carbon off, some of that solar energy that's taken the atmospheric carbon, turned it into sugars and proteins. But down below ground where the soil carbon is, our residues will contribute to that. And sort of the old paradigm people have probably taught you is that you want to build organic matter, you got to add stuff to your soil. We're thinking of adding crop residues. Taking compost, put it on the top. That's not the way to build soil organic matter. That's not the way nature's ever built soil organic matter. It's much more efficient to do it from the bottom. It's the roots that really count. And down here, this root system is mostly invisible. You pull up a plant and you get just a tiny fraction of it. It really takes a lot of effort, and there's not a whole lot of data on it because it takes so much effort to do. So it's hard research to do. We'll see some of those roots in the pit. It'll be a lot more than you probably expected. But that's where the carbon really counts. You want to think about what kind of roots do I have. One of the worst articles I ever read was in Science, one of the leading scientific journals, back when they were starting to talk about making biofuels, growing fuel. You know, we've been around the ethanol circle and stuff like that. But it's a concept that, you know, getting solar energy, turning into crops, and running our vehicles on it. We're probably going to have a role to play. Well, they were talking about we need to genetically engineer our crops so it's all in the stover where we can harvest and turn into methanol. And so they wanted to design plants that would have as little as possible in the roots. In other words, put all the energy into the shoots where we can harvest. Like, oh, no. You're not going to do that very long. You're going to be starving the soil and the whole system's going to collapse. So there's this lack of understanding, even in the scientific community. You find it all over the place. Soils are just this sort of black box people don't understand. So it's really not only the roots themselves, You know, the plant died, you take your soybean off, all those roots are down there. You probably got almost as much below ground as you took off above ground. But while the plant, you can't measure that just by looking at, even if you could pull all the roots out. Because while the plant's growing, it's actively exuding compounds into the soil. That's how the plants talk to each other. Did you know your plants are talking to each other? You think that's sort of crazy, right? Plants talk to each other kind of the way dogs do. You ever watch dogs talk to each other? Right? Dogs will sniff each other's butt and droppings, whatever, you know, it's all about smell for a dog. For plants, it's all about chemical compounds. They're not smelling with nose, but they're sensing these compounds, signaling compounds. We're just starting to learn about these. Plants send out signaling compounds that talk to each other. They talk to the organisms in the soil. When a plant has an enemy attack it, we know that certain corn varieties will respond. We've done the biochemistry on this now, and some varieties are breeding programs. When you're just breeding for yield, or you're breeding for Roundup resistance, you lose some of these traits because we didn't even know they were there, so how you can breed for them. But we know that some varieties, for instance, when they're attacked by a nematode, will send out a signal that will recruit other nematodes that eat that. In other words, they'll say, hey, I've got an enemy here. They'll actually recruit the right bacteria or the right fungi or the right nematode to come in and give them some protection. This will even happen when they get attacked on leaves. It changes the chemistry of the roots. So this is going on all the time. And it's a large amount. The plant knows it's living in a hostile environment. It's hard to get nutrients out of it, and water, and protection in the soil. So it's feeding that environment in order to create a population in the rhizosphere right around the root. So the roots are continuously exuding something like a third or 30-40% of all the photosynthate that the plant produces goes down to the roots and then gets exuded into the soil by the fine roots. The plant's doing that on purpose. It's doing that to create an environment which is good for it. So if you're trying to build organic matter, you can add carotenoid leaves. If you add a whole bunch of material, you know, most of it decomposes pretty quickly and goes back into the atmosphere where it came from. And you might get from 100 pounds to 100 kilograms of carbon that you added as leaf residues. You might end up after a year having maybe 15 or so. About 15% of it's likely to stabilize in the soil, a little bit less than that long term. But with roots, you get about twice as much. So there's a little less down below ground, but the roots don't decompose so fast, and they turn into more organic matter. The less of it goes back into the atmosphere, the more of it turns into organic matter. Some of that's got to do with the composition of the roots, but a lot of it has to do with where the roots are. The roots are in the middle of aggregates, where the material is going to be, when that dies, that root's going to be protected. Aggregates are the key to soil function. That's what you're looking at here. We're looking at aggregates. We're looking at the clay all clumped together in a system where it's providing an environment and places for the bacteria to live, and it's providing places where organic matter can hide from bacteria. And it's providing places where some microbes can hide from their predators, and that's what builds up organic matter and releases nutrients over time. We want to think about roots to get the kind of soil that is going to really work for us. And you see this difference. You know what a good soil looks like. You know what it smells like, how it falls apart. We'll see some of that. Dave's got some of the best. Well, these are some coastal plain soils from Maryland where we got these old soils. They weren't glaciated 10,000 years ago. They washed up on the beach about 10 to 20 million years ago. Not much organic matter in them. The difference here, one that's had cover crops and perennials growing on it, it's about 2% organic matter. This is organic matter, not just carbon. Carbon is about half the organic matter is carbon. And the other one has been tilled. It's for about 20 years. So it drove the organic matter down from 2 to about 1.2. The part that gets used up is the active part that microbes can feed on. There's another part of the organic matter that's sort of stable and it isn't involved in this process so much. Look what happens when we add water to these two beakers. You can do this with your soil, just sort of dry it, sieve it out. It's somewhat similar to this sledging method. just added water to these beakers, and that's what it looked like. There's water in that beaker on the right. Look at it. It just absorbed all that water and stayed intact. The water moves on through. Just totally dissolved the slate and stuff on the left. And when you dry that out, you know what the surface of your soil looks like. This looks just like the fields. I can walk across, I dug up and brought it over to the soil pit. That one on the left looks just like the field across the street. And you know what happens when the rain falls on that, right? It all ends up in the ditch, the roadside. So you put cover crops into the mix, and you're adding this organic matter that the microbes can use. So organic matter is a little bit like money. You can make money and put it under the mattress and keep making it and putting it under the mattress, and it probably wouldn't do you much good, right? But you can store organic matter in the soil, but money does you good when you spend it, right? If you want to get any good out of money, you got to spend it. And the same thing with organic matter. Organic matter works for us when it gets eaten up. That's when it releases nutrients, when it supports all the microbes that are making the soil work. So it's the same problem you have with finances. You want to spend it, you don't want to put it under the mattress. So there's really only one thing you do. If you spend it and don't make it, you know what happens. You go bankrupt. And that's what's happening to our soil. So if you want to get the benefit of both, you get yourself a decent job, you're producing crops, you sell them, you make money, and you spend money. You got cash flow. You need some cash flow in the soil. That's what you need. That's what you're aiming for is cash flow, and that's what your cover crops are giving you. It's an input so that you can use that and spend it. You can't spend it unless you're putting it in. So just to show you sort of an impact on the biology, this stuff is hard to study. I had what you're looking at took a graduate student about 2 years to figure out, of work. But we just put in a number of cover crops. We had control, it was just the weeds over the winter. Forage radish, oilseed radish. We were looking at brassicas. We had some rape, rose in the spring, and we had some rye. 2 different soils, Beltsville and Salisbury. One's a silt loam, one's a sandy loam. And we had this particular species of nematode. This is a fungus-feeding nematode. So most of the nematodes don't feed on your plants. There's hundreds of thousands, actually thousands of species of nematodes in your soil. Most of them are beneficial. Few of them, when they get out of hand, feed on plants. This one feeds on fungi. You want things to feed on fungi. If you just have fungi and bacteria growing, the nutrients all get stored in that biomass. The plants can't use it. You need to have predators that eat that biomass that then excrete the nutrients and release those nutrients to your plants. A lot of people don't understand that. They think, oh, a lot of bacteria is good. Well, a lot of bacteria is good, but you want the stuff eating the bacteria. Otherwise, the colonies just get big and synapse, and all the nutrients are tied up in the biomass. And that's what nematodes do. There are lots of things. That's what earthworms do. You think earthworms are eating the leaves? Eating your crop residues? That's not what they're actually eating. That's the packaging. What they're eating is the bacteria and fungi growing on the crop residues. That's why you see, how many of you have grown radish cover crops? Some of you have grown that. Yeah, I've kind of been working on that now for about longer than I ever thought I'd be working on it. I brought that up, got that started. And one of the things you'll notice is the earthworms around the radishes. You ever dug up a radish? It's crawling with earthworms. The earthworms are eating the bacteria. The radish is full of sugar, and the sugar supports the bacteria, and the earthworms are eating those bacteria. And then they go about, of course, making channels and doing good things in the soil. Okay? So let me just show you what this data looks like. Both soils. This is one cover crop, and this data is from 9 months later. This is data taken the next fall. We sampled and you do this under the microscope hour after hour and separate all the different kinds of nematodes here. And you can see that this species was really stimulated by having these spring-killed cover crops, whether it was rye or not. And this was still there. It changed it to a fungal-based system by growing a particular cover crop at a particular time. Now the radish was pretty low in these, but it increased other nematodes, which were the bacteria eaters, because the radish in fall tended to change it to a bacterial-based system. So you can control your microbiology by controlling the kind of cover crops, and this has a fairly long-term effect on your soil. So earthworms are a really good indicator species, and they're really important for our agricultural soil. Even though most of our earthworms are invasive foreigners from Europe, and they cause all kinds of havoc up in the forest. And you think of earthworms as being good, but if you're looking at the northern forests in northern Minnesota, they didn't have any earthworms up there, and they developed these thick layers of mulch in the forest floor, and all kinds of species of salamanders and other both plants and animals that are native to that. And then some fisherman throws the bait out on the shore, and now you've got earthworms that start to take over, and it's amazing. Within a few years, that entire litter layer gets incorporated into the soil, and now those species have no place to live. So they can be a problem too. But in agricultural soil, they're really very beneficial for a lot of reasons. Now this earthworm on the right there, do you know what he's doing? I shouldn't say he. Earthworms are sort of bisexual, right? He or she. He and she, right? You know what he's doing? It's hybridated, called estivated. And if you go down in winter, you won't find earthworms in winter or in the middle of summer when it's too dry. When it's either too dry or too cold for them, they'll turn into a tight ball and turn their metabolism way down. That's how they survive those periods. So right now it's beautiful. They're warming up, it's still cool. You dig a shovel full of decent soil, you ought to have half a dozen earthworms in every shovel. If you dig a shovel full of your soil and you don't find an earthworm in it this time of year, you need to do some soul searching. You're shorting yourself and your farm. Something's wrong. And with these earthworms, especially the big night crawlers, we have some species that crawl around the surface, some that work in the compost, the litter layers, and the big earthworms, the night crawlers, they go down deep and vertical, and they have particular advantages, and they'll go down 3, 4, 5, 6 feet. Around here, they probably go down until they hit the glacial till, and then they probably quit down there. And they'll create these channels that you see here, and then the roots will fall. And every year, the roots will go down, and that's how a forest works. That's how the prairie works, natural systems work. The roots don't push a new path every time. They need to go through the soil. They go through the paths that were created by the predecessors. 90% of the root growth in the forest is going through old root channels. And that's what happens in the no-till field with cover crops. Your crop roots are just zooming down these earthworm channels and root channels. And these channels we'll see them out in the field, they become coated with all the leftovers of these generations of dead roots and excretions from the earthworm. So they're loaded with nutrients and organic matter, and they also absorb pesticides, by the way, because they have a real high CEC on the walls of these channels. And so you've really made it easy for your plants to get down deep. We'll talk out in the field about how important it is to get down deep. A lot of farmers think of soil, they think of topsoil, about 6 to 10 inches. And soil as a whole, if that's all you're farming, you've got a lot of problems. You better have irrigation, you better be pouring on nutrients, you're still not going to do very well. A lot of us are farming, especially if we've been plowing, we're farming at the top, 6 to 10 inches. And your roots never get much past it. So you need to start thinking of soil as being 4 feet, 5 feet, 6 feet, sometimes more. There's a lot of nutrients and water down there. The cover crops work together with the biology in ways that just growing corn and soybeans is not going to do for you. And a lot of this is about the roots. We don't see the roots, so we have to pay special attention to it. And I always get a kick out of this. I got started with radish work when I visited Brazil. Southern Brazil has a climate, just down in the very southern part of Brazil, has a climate not too different from where I was from in Maryland. So I was looking at some of their practices, and they used a lot of brassicas. They learned no-till from the Americans 30 years ago, but they kept the cover crops in. And most of the no-till in the U.S. dropped it out. And they really were serious about cover crops. I drive up the lane, on a big farm. They have all kinds of different size farms. They have some folks that are still plowing behind horses and small farms, and they have others that are, big machinery. And you drive down the lane, how you drive up the lane here, and someone's got different herbicides along the lane that they're testing, different varieties, corn, that kind of thing. drove up the lane, they had all these different little signs up there in plots as you drove up and looked at them. They're different cover crops. This was in the year 2000. I said, these guys are serious about cover crops. That's great. And I brought some of these ideas back, and we started looking at a project. It was a SARE-funded project, so it had to involve farmers. One of the great moves by the USDA was to come up with this SARE program that made the researchers talk to the farmers. They said, we're going to put farmers on a panel that decides who's going to get what grants. That was a great idea. And we want farmers to be, you're going to be working with farmers and not doing stuff off an experiment station where it kind of gets lost and you never know about it. So I brought some of these ideas back, and Steve Groff was a guy that I've been working with for a while up in Pennsylvania. You've probably heard of Steve. He's got the cover crop solutions and all this kind of came from this. And we started growing some test plots, and he really liked these, and we had a big field day, kind of like this. He's been doing these for quite a long time. And again, just like Dave, it started with the farmers. And pretty soon the agency folks wanted to get in on the act, and they helped support some of the field days. But he started it on his own, just him and his wife. And I remember one day we had a lot of rain, just like we got on Monday. I don't know, it was 2-3 inches of rain. It was pouring. And he had some tents over the soil pit for me. He must have had 300, 400 people there. Where are you going to park all these cars? Now Steve grew, at the time especially, he grew a lot of vegetables. So he had corn and soybeans, but his main cash crop were things like tomatoes, pumpkins, and he grew some peppers. So he grew a lot of these vegetables. And he was the only no-till vegetable grower that I knew at that time. He did no-till transplanting. He transplanted cabbages no-till into rolled cover crops. He was doing some really interesting things. So he had 300 pickup trucks parked on his tomato field. Now you couldn't do that if it was a plowed field, but this was a no-till field. Tomatoes were gone. And we had the cover, and he said, well, that's a good place for us to test this compaction business, because I was trying to look at how cover crops would deviate compaction, whether these roots would make a difference. And it worked pretty well up on his farm. He said, you know, that really did the job. He was long-term no-tiller, but he used to have a ripper where his heavy harvest trucks would go through his fields. And he'd have to harvest when it was wet, and that would sometimes create these compacted zones. And he finally parked his ripper. He made what he called the radish ripper. He just planted a couple of rows of radish instead of ripping up those tire tracks. And he found that it did just as well. So that's kind of where that originates. We'll talk about that some more in the soil pit after the talk. So the roots are a really important part of this, but also the residue is a really important part. What's on the surface makes a big difference as to how these are going to behave. Here's a couple of plots side by side. Now these are both winter killed. You know, spring's a busy time, and it's kind of nice if the cover crop kills itself for you. Right? It gets out of the way, it says, all right, I've done my thing, I'm out of the way, now you can go ahead and deal with me. The one on the right is spring oats. They'll grow like crazy in fall, but when it gets good and cold down into the teens, it'll die. And the one on the left is the forage radish. Steve keeps wanting me to call it tillage radish, but of course there are other brands and varieties out there. So I just use the word forage radish. So this will have a big effect on soil temperature. You got a lot of residue, it's going to keep your soil cool. You may not want that in spring. You may want to have a zone where you're going to plant, where you don't have a lot of residue. Now think about that. You can do this with cover crops. The forage radish, or the radish cover crop, kind of goes through this cycle, and it's kind of a unique plant that you can use in mixes and you can use different ways. But it grows like crazy. It's terrifically competitive in fall. And you can get, if you get a stand like this, I can tell you right now that's got a couple 100 pounds of nitrogen in it per acre. It's going to get released. It's not nitrogen it's going to hold on to like a rye crop will, but it's nitrogen that's going to get released. Part of that's going to be available to your next crop. It's also going to give you a virtually 100% weed-free, friable, warm, drier seed bed, at least for that planting window right at the beginning of the planting season. You're going to get summer weeds coming in. We have to do something about those. This is going to disappear over the winter. It's going to look like this in the winter, and by now it's going to be pretty bare. So that may be a little bit of a problem for erosion, although you don't get a lot of runoff when you have that many holes. Big radish hole. the soil is wrapped up in saran wrap for a couple of months. You have this thin film. So I measured erosion from these, and it's usually very low. Hard to get runoff, but you can get some, but it's not good cover. But you do get this very good weed control. So this is a way of controlling temperature. It's like doing a little strip tillage. You have very little residue, and we will get warmer temperatures here. The shaded area is with the radish, and the high and low temperature, this is during April, with rye. So you got shade, if you got a growing plant, a dead plant, it's going to keep the soil cool, it's going to warm up more slowly in spring. So this is going to allow you to plant earlier. It's also going to dry down. All those holes create drainage. You'll see the soil is drier and more friable. So here's, you can see the low level here is where you have the radish growing, and the higher moisture content is where the rye is growing. So you can control this by the kind of cover crop you plant and where you plant it. Now this is some data that's just hot off the press. This spring. We had moisture sensors at different depths down to about 2.5 feet deep. And in the surface, you can see that the solid line is forage radish, and the dotted line is no coverage between the weeds, chickweed, and things like that. And you can see that the surface soil, the top few inches, dried off. Okay, it's drier. This is January through here, all the way through the middle of March. We're actually planting early vegetables after this. Around a foot deep, there wasn't much difference. Around 2 and 2.5 feet deep, it was wetter when where you had the radish. Get back to that. That's the wrong button. So this is there was more water that came down. It dried off the surface, but the water moved on down these channels, and you had more water stored in the subsoil. But this is the first time I've seen this, but I think this has some real implications for drier parts of the country. The subsoil is absorbing water, and the surface is drying off, kind of what you want it to do. So one way to use mixtures, rather than mix them up randomly, which is a good thing to do if you're going to graze them, is to zone this. So there's certain things you want to happen in certain parts of the field. So this is an example where we've got radishes planted on, these are going to be vegetable beds, but you can put them down where you're going to put corn row. You can do this with precision planting. And we've got oats or some high residue material in between, so you'll have the summer mulch that's going to keep water from evaporating. The other thing that these crops do is these cover crops have much deeper roots than you might expect, and they cycle nutrients. The legumes add nitrogen, but the others cycle nutrients. They cycle it from deep to low. They've got a lot of nutrient issues that cover crops can help us manage, and one of them has to do with pollution issues. So we're up here where we worry about Lake Erie, or we worry about the Gulf of Mexico. At least the folks around Lake Erie worry about it, and they know where their phosphorus is coming from and making the algae bloom. I'm from over here where we've got the Chesapeake Bay, and we've got problems with nitrogen and phosphorus there. And so we've been dealing with that for a long time in Maryland. And there's two reasons to be concerned. One is that we want to be good managers of the land and not cause these water pollution problems. If we don't do it, we're going to get regulated for doing it. And the other thing is, it's money down the drain. I mean, it's just stupid to let nutrients, buy them in a bag and then let them run down the drain. But we don't want to do that. One of the problems is in fall, think about your corn crop. You might harvest, I'm just guessing you probably harvest, say, mid-October. Okay, let's say your corn's ready to harvest in mid-October. When did it stop taking up nutrients? When does your corn stop taking up nutrients? Most of the nutrients are taken up by the time it tassels. That's right. And there's still a little bit, and most of what goes on after tasseling, and your corn's forming grain, most of that is transferring nutrients from one part of the plant to the other. There's still some nutrient uptake, but by the time your grain is starting to fill out, all the plant's efforts going into filling those seeds, and it stops sending food to the roots, and the roots are dying off. So sometime in August, your corn plant's pretty much pooped out in terms of sucking nutrients up. You need to provide those nutrients when it's growing, up through tasseling and beginning. That's when it needs to have a lot of nutrients in the soil. So there you are in the middle of August, and you're not going to harvest until October. It's got to finish finish filling the grain, and then it's going to black layer, and then the plant's going to start drying down, and you're not going to be able to harvest that until it's dried down. So you've got a couple of months in there, a month and a half or so, where you've got a crop standing in the field, basically not doing anything. The roots are dying, and that's feeding the microbes, but there's no nutrient uptake. But the bugs haven't taken a vacation. That organic matter in your soil is still decomposing and releasing nutrients. But now there's nobody to take it up. And this is what Dave's machines are trying to deal with. You want to have something growing under that crop. You want to be relayed. You don't want to wait until after harvest to establish a cover crop. You want it to be getting down there. So this is just some data showing nitrate. This is some data from Ken Staber at the university. And this is nitrate in the top 6 inches, and this is in the 6 to 12 inches, so in the upper part of the subsoil. You know, in a corn crop, we grew 160 bushel of corn, put on 140 pounds of nitrogen on, so it's fairly typical production from Maryland. But you can see the nitrate is rising here during September and October. The weather's still warm, the soil's still got good conditions for microbial activity. And so you're producing nitrate, which is very leachable. And the nitrogen that's in the organic matter is stable, but that gets released into this soluble salt. It's just like it comes out of a bag of fertilizer, and it's going to wash out or go into the air, one or the other. And so we need to catch that. In this case, it's only about 6 parts per million. That's about 12 pounds per acre. That's 12 pounds per acre per 6 inches. But this is going on more than in the top 6 inches. We got organic matter mineralizing throughout the soil. You'll also find that this tends to wash down every fall, and so you'll have fertilizer and mineralization that took place last year. You'll find that a few feet deep in your soil. And you'll find 2 years ago a few feet deep. So when you start measuring nitrate down through the profile, it's amazing how much nitrogen you have under your farms, and yet you're buying more. You're spending money to buy more, and you're just letting all that stuff go into Lake Erie. So we have these problems in Maryland, and some of you probably know that Maryland is, we had some environmental crises with the Chesapeake Bay. In the late 90s, we had a voluntary nutrient management program starting in the 80s. I started working on this with irrigated fields with farmers in our chicken producing area, and the farmers had no idea what the nutrients were in the chicken manure. They just put it on because they knew it was good. They had it, and so they spread it on. And they had a loan from the bank, and the bank wanted them to fertilize for maximum yield, so they fertilized too. But you couldn't take credit for what you didn't know. So I was measuring nitrate in the groundwater under these farms. These are irrigated, center pivot irrigation, so that means you're going to wash this stuff out pretty fast. And I was finding a lot of nitrate under these farms. Well, that's not good for the farmer, and of course it's not good for the bag. So the first thing that Maryland did was offer free manure analysis. They figured, well, if the farmer knows what's in it, they can at least cut down and just put on 5 tons of manure. Well, we found out people were putting on 10, 12, 15 tons of poultry manure, and old-fashioned spreaders. Once we started analyzing, we found out not only did we need a lot less, we needed to come up with a new kind of spreader. You couldn't spread 3 tons of poultry manure, which is all you needed. With the spreaders we had to come up with better spreaders, because you only needed a little bit. Well, pretty soon it didn't solve the problem. The Chesapeake Bay is still dying. We used to be the oyster capital of the world. The world. Baltimore was where you went for oysters. They had oysters they sent over all around the world. You get oysters in a restaurant today. Do you think they came from the Chesapeake Bay? I doubt that they even came from the Gulf of Mexico. They probably came from Vietnam or something. The oysters are virtually dead. They're trying to bring them back. So the Chesapeake Bay has some problems. And so we're pretty serious about trying to do something about it. And the states, Maryland, Virginia, all the way up to New York State. The Susquehanna River comes on down from southern New York State, West Virginia, all the states, including the District of Columbia, came to an agreement with the EPA to try to reduce the load of nutrients in the Chesapeake Bay. They had a multi-state agreement to reduce it by 40%. That's what they figured would be necessary trying to help the bay back. This was back in the late 80s. And they started working on nitrogen, and they had this tributary strategy, the way we did it there. Based it on watersheds, not counties or states, but watersheds. And the citizens got together, you guys got together in the watershed, you had to figure out, well, how are we going to reduce 40%, by 40%, our nitrogen and phosphorus load? That's how they did it. So they had different goals, and these are some of them. This is an example of one of the watersheds they're planning. Okay, so they had they're close to each other. So they were using conservation tillage, nutrient management, and cover crops. And one of the things they were doing in order to reduce, you can see the cover crops were going to be really effective, they figured, in reducing the nitrogen load especially. So that was a major thing. So this is just one little watershed in Maryland decided that they had a goal of putting in about 50,000 acres of cover crops in order to reduce the nitrogen load, along with all these other things. Okay? So we have this state program that was voluntary to begin with, and we're getting a lot of people doing it, but then we had this toxic yellow bloom which got people pretty worked up. And there's people who've got medical issues with toxic algae, and they decided they're going to make it mandatory. They did, probably wasn't the best decision in the world. I was talking to a fellow this morning, and they said, you know, if you've got 10 acres or so, you probably need to have a nutrient management plan. I think that's how they're doing it here. I think that's what they had in their mind. You know, a substantial field, 10 acres, probably enough to regulate, but they didn't go with acres, they went with dollars. And I'm sure they were thinking this way. I think they were thinking corn and soybean. So they said, if you're selling $2,500 worth of ag products, you need a nutrient management plan. And that probably worked for most of you. But suppose you had a market garden and we're growing strawberries. You realize that with a small patch of land you can grow $2,500 worth of strawberries on? So we've got a lot of people in Maryland that are caught by this nutrient management planning that I think the regulators did a really neat catch, but they're not going back. Everybody, virtually anybody who's growing anything has a nutrient management plan now. And one of the things they do, but it's all carrots. I mean, there's not many sticks. We give them a lot of carrots. And that's because the citizens in Maryland voted to increase their taxes to support this agricultural practice. We do it through the flush tax, we call it. Because the sewage fees have been increased because sewage is part of this whole nutrient cycling thing, and some of that money goes to build sewage plants, but some of it goes to pay farmers to put in cover crops. So we have this cover crop program. You can go online and see it. And I'm glad you're all sitting down, because I'm sure you don't have this in Ohio. We advertise it, and they really like rye, because this cover crop program is not focused on soil health. It's not focused on making your farms more profitable or more diverse or better for the next generation or any of that. It's focused on reducing the nitrogen load to the Chesapeake Bay. Rye is pretty good at that. You can plant it late, after harvest, still get some growth, and still get some pickup. But I don't think they're being good enough. Anyway, we got this advertised. If you can't read that small print, I'll make it larger for you. This is what they're paying. Oh, it gets better than this. And it took a lot of discussion to get forage radish and some of these other crops in on the list. You don't see mixtures there, so you won't get paid for mixtures yet, but we're working on that. Give it time, it takes a while. But you can see you get 35, 45, 50, for rye, up to $55 an acre. Plant rye. Now they want you to plant a heavy rate, 112 pounds, to make sure you got a bunch out there. Back up. You can get a little extras. You can go all the way up to $105 an acre. If you plant rye, you get extra for planting early. You get extra if it was a field that had manure on it. In other words, they're aiming for nitrogen. So if you do everything to maximize the reduction of nitrogen, you can get up to $105 an acre for planting rye cover crops. So no wonder we have a lot of cover crops in Maryland, right? And we have the data to show, this is the kind of data that convinced the regulators that decided they wanted to do something. This is groundwater nitrate, shallow groundwater in wells under conventional and no-till long-term field experiments. And you can see here where they started putting in winter cover crops. This is where they started planting rye after corn. So it was up around 15, 20 parts per million nitrate nitrogen, which is too high. That's actually above the drinking water limit. And here's where they put them in. Now you can see if you only looked at 1 or 2 years, you'd say, oh, that doesn't work. All right, this is 1988, 1989, they started putting them in here. But pretty soon, both the conventional and the no-till dropped first. But by the mid-90s, they were down here around 4 or 5 parts per million, which is about as good as you're probably going to get under agriculture. And they're both pretty low. So this is the kind of data that convinced them that the cheapest, fastest way to get nitrogen out of the bay is to recover crops on the land, especially something like rye. And we only have about 1.5 million acres of land, farmland in Maryland. And about a third of that, about 500,000 corn, 500,000 soybean, and then the rest is small grain and vegetables. So we've got about 1 million acres really that could use cover crops. And out of that million, we've got about 400,000 cover crops. Okay, that's a little state, not a whole lot of agriculture. Can't see the dates. This is back in 1997, the first year of the program. They were paying around $25 an acre. And then went up to about 35 on average. See that jumped up. And now they're up around numbers I just showed you, typically about 35, 40, 45, 50. 50 is the average. The goal is higher than 105. And the goal was 350, and we passed that goal. We're now up over 400,000 acres of cover crops in the state of Maryland. So when you drive through Maryland, it doesn't look like driving through Ohio. I drove through Ohio, and I passed Jefferson Farms. They got crops growing, but their houses. I don't know if you saw those. But then you came to Dave's fields were green, but that's about the only ones I saw. There was a horse farm that had some rye on it I passed too. But you can drive through the state of Ohio or Indiana, well now, and pass literally thousands of fields, and you won't find but a few that have cover crops. You drive through the eastern shore of Maryland where the big egg is, and most of those fields are covered. It's very rare to find a field that doesn't have something green going. But what did that do? This is the hard part. If you think you're going to clean up Lake Erie and solve those problems overnight, it ain't going to happen. It's a long-term thing. There's a long delay. So this is actually the river. This is from one of the watersheds in Maryland. This is the water quality in the rivers. A number of different rivers. Each of those lines is a different stream. This one down here has only got about 45% cropland in the watershed. So it's more than half forested, and it's pretty low. It's only about 1 part per million nitrate nitrogen. These are about 80% cropland. These are agricultural watersheds. And this is 1988 to 94, it was going up. It was getting worse, more and more nitrogen. We started the cover crop program, and the best we can say is we've stopped the increase. Now, we've certainly put less on that. We have nutrient management, but we stopped putting on the excess manure. We cut way back on the nitrogen, and I don't know why the Midwest didn't look over and say, hey, they're doing that, why don't we do that? And we're growing the same sort of crops that you are. And we used to recommend, what they used to recommend, you want to grow a bushel of corn, you need to put on 1.4 pounds of nitrogen per bushel. Do you remember that? What are they recommending now? So we're down. And so we did that back in the late 80s. We started recommending less. That didn't affect yields. Less didn't affect yields. You know, we way over-recommended. That fertilizer was great stuff in the 60s. And the more the better. Way over-recommended. So we did all that already. We're down to about 0.7, 0.8 of what we think we need. Regulating manure and all that. Putting in cover crops. And we're still only able to level off. The reason for that is the time it takes for nitrogen, which mostly gets to the bay or the lake by leaching through the soil, to get off the fields down to the drainage and off the field. If you don't have tile drainage, it takes years to get from the middle of the field down to the ditch or the nearest stream. And this map is a little watershed here. It's a couple of miles across. And the red area is just a few years, but these areas out here that are blue and purple is up to 30 or 40 years. That's the residence time before that water gets into the stream. So it's a hard political sell. The citizens of Maryland, the taxpayers, are spending a lot of money to put these cover crops out, and we still don't see what we want to see in the bay. So it's a difficult situation to try to convince them to keep doing it, because that's what we need to do. Now, I don't think they need to do it. You probably don't think they need to do it. You'd probably take it if somebody offered you $105 an acre. But I think you guys know the cover crop pay. If you use the right cover crop for your system, it's something you want to do. It's not something you need to do. So the conversation goes different in Maryland. Farmers in Maryland are used to thinking of cover crops as something that, well, you know, it's a pain in the butt, but if they're going to pay me to do it, and, you know, I'll do my part and I'll take a check. It's a bit of extra paperwork, a lot of extra trouble. It's not something they want to do. And they're just looking at usually something as simple as possible. It's usually rye, and it's usually right after, you know, planted late. And I'm not sure it does a whole lot of good. Well, just look at what's out there and why you want to put cover crops in, whether someone's paying you or not. In fact, you probably don't want anyone paying you, because then they're going to tell you how to do it, and it's going to make it a lot harder to do it the right way. This is under a field on a dairy farm that has not had any manure on it for about 10 years. And we put out these plots out here, just had a field day. We actually measured this with the farmers in the field. We augered down, had a little nitrate meter in which we measured this in the field. And we've got the forage radish. You can see here's a radish cover crop, because it goes down really deep, really fast in fall. And this is data from, this was late December 3rd, okay? Where we had no cover crop, we found a whole pile of nitrogen down here. This is nitrate nitrogen. Altogether in the top 3 feet, we found 225 kilograms per hectare. That's pretty close to pounds per acre. Over 200 pounds per acre of nitrogen in the top 3 feet of soil. Just sitting there in the nitrate form. That's soluble. That's going to wash away. And where we grew the radish, it was all in the radish. It was down, you couldn't measure any down in the lower soil. There was a little in the upper soil where the radish was releasing it already. Which is where you want it. You want nitrogen in the top. The crop can get it. Don't want it 3 feet deep. So we've seen this over and over again, especially on fields that have a history of manure, because that manure keeps mineralizing long after your crops have stopped taking it up. And there's this missing nitrogen problem. So this is some data from a similar field. We got nitrogen that's in the biomass of the cover crops, including weeds. These are just weeds. And we got nitrogen in the soil. And you can see that there was about 150 pounds or kilograms per hectare, pound per acre of nitrogen taken up. But in the upper meter of soil, that's a little over 3 feet, we only could see a reduction of 40 pounds or kilograms of nitrogen. So 150 is taken up, only about 40 has disappeared. So that begs the question of where's the rest of that nitrogen coming from? Some of it might be current mineralization, but I think most of it's coming from deeper. We're not thinking deep enough. You know, all our soil tests are top 6 or 10 inches, and I think even the meter is not deep enough. I think we need to go deeper. Now, this is hard to do, needless to say. When we go deeper, sure enough, we find nitrogen. This is on a very sandy soil, as you can see here. And this is, we went down to 180 centimeters, that's about 7 feet deep. Okay? And you found the, this little thing is driving me nuts. We found fertilizer from the last application down here, sucked up by the cover crop. This is the no cover, this is the different cover crops. And this is from 2 years ago. They'd gotten down, that fertilizer bulge had moved on down a little further. We got a series of these. You know, unless you got hard rock, you've got a long way that you can go down and get this. And you can see that the cover crop cleaned that up at 7 feet deep. I didn't go any deeper. It was as deep as I could get with the equipment I had. But I think if I went deeper, I would have found it got deeper. So that cover crop sent its roots down there in fall, in a couple of months, 7 feet deep. Like I said, I think it's deeper. So this is, I think, where our problem is with the way we're doing cover crops in Maryland. This is basically what we're doing. In September, corn is dead and waiting for harvest. And we've got nitrogen, some at the top mineralizing, but we've got a fair amount down here. It's not real high, maybe 10, 15 parts per million. But you add that up and it adds up to hundreds of pounds per acre. We plant the cover crop in, let's say if we're lucky, in early or mid-October, and it starts to grow. There's not much there. If you try to measure the nitrogen in that little rye cover crop, you can hardly measure it. It's almost nothing there, a couple of pounds. Maybe by the end of fall, it might have 10 pounds or so. There's not much there. There's not much biomass out there. It looks a little bit, a little less than what you're going to see out in the field right now. Then it starts to green up in March, and then we kill it sometime in April because we're going to plant. Maybe we let it take up 40, 50 pounds of nitrogen before we kill it. That's the way they're doing it. That's not taking much up. What's happened, of course, is all this deep nitrogen, the roots never got down there, and it's getting lost. You never got a chance to catch it. I think what we need to do if we're going to catch that nitrogen, which is not only good for the environment, but good for the bottom line, is we need to plant it early. We need to get in there when the corn stops taking up nutrients. We need to get some roots picking that up. We need to get something that grows fast. So if you get something like this radish and planted in September, if you can, fly it on, blow it on. It doesn't do too much, but you'll have maybe 25 pounds by the end of September before you ever harvest the corn. Just from the light coming down into this drying corn. And then it really takes off. Those of you who have planted some of these cool season cover crops, the radish is just kind of a rock star in that. It really is aggressive and impressive. It'll take off, and you'll get a couple hundred pounds of nitrogen in that before Thanksgiving, before it gets cold enough to kill it. And that's nitrogen that didn't just come from the surface, but it'll clean up the profile. Those roots go on down 6, 7, 8 feet or more. Like I said, the deepest we measured is 8 feet. And then they die. And they immediately start releasing some of that nitrogen. Some of that nitrogen is already soluble in the plant. When it dies, it gets released. Get fertilized. Not the best time of year to fertilize, maybe. Probably under snow. It's on frozen ground. But as early as you can get on that, you've now taken nitrogen that was 7 feet deep and you've brought it to the surface, but you want to get on there fast and catch it. Because it's going to start moving down again. But that way, you can take a credit for this nitrogen. With the rye system, nobody's reducing their fertilizer because they're planting the rye cover crop. They might have to increase it. If they let the rye get away, it'll actually tie up some nitrogen. In this system, you get it in early with a cover crop that decomposes fast, at least part of it will be part of the mixture. You can take some credit for that nitrogen. I think you can cut out at least 50 pounds of nitrogen from what you put on. Maybe more. So that pays for itself right there. And that'll put less nitrogen into the whole system so that it will become less leaky. I think that's what we need to try to work with.
Right.
Yeah.
Based on your experience with people in northern environments, how soon is too soon to start trying to seed cover crops like in a relay situation, so it's not a competitor with intended crop plant harvest?
So I think what innovative farmers are looking at now, they understand. Once you understand, you start thinking about solutions, right? I'm trying to give you the understanding. You think of your solutions. Everybody's environment's different. You're from Ontario. It's pretty cold. You have a shorter growing season. Once your corn's up about a foot, side dressing time, you don't have to worry about a competitor. Any seed you put in the ground there doesn't have a chance to compete with corn. And corn's canopy, even soybean canopy will close over and will take care of it. It'll dominate the light, and it's not going to be a competitor. The question is whether what you're planting, if you're putting seed on, say, at side dress, you could put it on, if you're putting it on at the same time, then you've got an intercropping situation with potential competition. But if you give that corn, a month and a half head start, I don't think you need to worry about competition. What you need to worry about is, can the cover crop survive under that dense corn canopy? And that depends on the species. And we don't have much information on that. Now, I've seen radish survive for a while. I'm not sure it's going to work that way. What I would do is I'd plant, one of these mixes with 16 in a raised crazy mix or something like that and see what survives. You know, you might have, you know, I would do a home brew and that would be the quickest way, and I'm sure in some years you'll have different ones, but you'd probably pretty quickly learn there are plants that will survive. You know, some of the crimson clover will do that. They may survive by the seed staying dormant and not germinating until it gets light, or it may survive as a little seedling that's stimulated and just barely making it. It doesn't look like much, but boy, it takes off as soon as harvest. Okay, I'm going to finish this. Yeah. Yes, Penn State is doing some work now, and they're starting to do work on these mixtures, and they have a little bit of data. The researchers are not out front on this. One point I want to make with these early cover crops is, especially with the radish, it's data for radish, that the later you plant, the less it's going to grow. It doesn't look, you know, very impressive. If you plant later, it has fewer growing degree days. But what we found is that the nitrogen content, the concentration goes up. So the biomass goes down. This is weeks after August 20th in Maryland. Biomass goes down, but the nitrogen content went up so that the amount of nitrogen taken up by the plant actually stayed stable in our environment up to about the first week of October. So you have some leeway there, even though the plants are small, they're really high in nitrogen. Yes, sir?
Does it hurt like that, you run the risk of your residual sprays?
Yes. The question was, do you have a risk of residual spray? Yes. You need, you know, the cover crops change everything in your system, but you also need to change your system to work with the cover crop. You obviously can't put out a mix of 16 different species if you have residual herbicide that's designed to kill, say, broadleaves or grasses. So you need to be thinking about the herbicide program, and probably last year's herbicide program as well. Some of these cover crops are very easy to kill. And that's a good thing if you want to kill it, right? But it's not a good thing. Yeah, I've definitely seen issues with different herbicide programs that have residual activity. Even in fall. You need to put it on in fall. Definitely an issue. This just shows you that, you know, we do find greatly reduced nitrogen. This is the release from radish and oats, so you can kind of choose your cover crops and choose how much and when the nitrogen is going to get released. You can see that the oats didn't release any, but mixing it with radish kind of gave it an in-between release and a little bit longer release. So this is about a 33 kilogram, 33 pounds per acre release of nitrogen right around planting time in spring. That's pretty nice boost as the weather turned warm. And we see responses. That's pretty nice when you put a cover crop in and you see an immediate response. This is actually a rye cover crop versus radish cover crop. Rye is taking up the nitrogen and holding it. The radish is releasing. And it's not just nitrogen. I want to mention a lot of other nutrients that are being brought up and down below, brought up to the surface. There's sulfur. I think sulfur has a big impact. It doesn't take much sulfur to give you a response, especially for small grain. And the radish, very high in sulfur. So the brassicas in general, very high in sulfur, phosphorus, and really high in calcium. So if you've got livestock and you're thinking about the calcium needs of the livestock or the calcium needs of your soil to stay aggregated, some of these cover crops will bring up very large amounts of those. So let's just leave you with these thoughts. You have 6, 7, 8, 9, 10 feet of soil, and the nutrients all the way through it, and you now have a tool, a way of capturing those and bringing them up to where your crops can use them. All right, well, we'll see you guys out in the soil pit, where we can talk a little bit more about the soil side.